Hi, so today in this video we're going to be covering chapter 6.1, which is the logarithmic functions and their graphs. Now, we did a really important thing in our last chapter, which was chapter 5.5, and it was to find the way, just get really familiar with switching from logarithmic form to exponential form and exponential form to logarithmic form. If you have not done that yet, I super highly recommend it. I'm pretty sure this is a chapter where it's basically just that. I don't remember. We'll get into the problems. But basically, if you don't do that, if you haven't done that yet, do that. It's going to be log base b to the a equals x is the same as log b to the x equals a. Oh, whoops. Oh, I'm having a weird time with my drawing tablet. Equals a. Let's just get into it. We want to evaluate the following logarithms. So we're basically solving them. A way to evaluate logarithms is to convert back into your exponential form. So we have 3 to the, equals 9. It's 2, right? We know 3 squared is equals 9. So 2 is our answer. We're solving for whatever our exponent is. Log 7 to the 343. Sorry, nope. It's going to be 7 to the question mark equals 343. I'm going to give a wild guess at 7 times 49. 7 times 7 times 7, which is, 343. So 7 cubed. If you are given something like this, you are going to be given something that works out nicely. So if you don't know, because I didn't know which one 343 is, but I know that they're not going to be something crazy like 3.36 for your exponent. They're going to give you something nice. Yeah, so I would do, if I'm confused at that point, I do, okay, 7 times 7 equals 49. Let's try times 7 again. Does that work? No, let's try times 7 again. No, go on like that, I guess, basically. But in this case, our answer is 3. In this case, our answer is 1, because 5 to the what equals 5? 1. Yeah, awesome. I'm going through this kind of quick, because I'm assuming, hopefully, you did your work in the last chapter, section. Use the definition of the logarithms to evaluate the following logarithms. Also, I will put the link to our last chapter section in the comment section. So we have log anything to the 1, log anything, 99,999, 100, 1 billion to the 1 will always equal 0. So we'll have 0 here. I also forgot to mention, if you have log without a base, like log 10, the base is assumed to be 10, log base 10. It's sort of like how if you have a square root, like something like this, it's assumed that there's a 2, even though it's not written. It's kind of what they decided. It's not like it's something crazy, like it's just going to be 10. So anyway, log base 10 to the 10 is going to equal 1. Like if you have log base 999 to the 999, it's always going to be equal to 1 if you have the same answer as your base. Bloop. So 1. Yeah, so now we have log, so it'd be 10 to the what equals 1, 2, 3, 4, 10,000. My guess is 4. So 10 times 10 times 10 times 10 is the same as 1, 2, because you keep the zeros, right? So 100, 1,000, 10,000. Yep. Awesome, so 4. Write an equivalent logarithmic equation for the following exponential equations and solve for x. We know in this case, so we're going to basically do x equals log base 4. Now, to do the base in Lumen, you're going to do shift underscore. Well, like shift minus, which does an underscore. So log base 4 to the 2. Log base 5 to the 4. Log base 3 to the 6. Now, I'm going through this quickly because I'm assuming that you've done your work and just gotten that down like a pro. Like a professional who has done that a billion times. Yeah, you'll get it. It'll be okay. It's if you haven't, it's okay. It's not hard. It just takes practice. Write an equivalent logarithmic equation for the following exponential equations and solve for x. Leave your answers in logarithmic form. Now, this is very similar to what we've done before. So we'll have log base 4 to the 4x plus 6 equals 6. That is what they're looking for. Log base 5, don't forget your parentheses, to the 6x minus 2 equals 1. No, sorry. Whoops. Oh, no, I'm doing crazy things. No. Okay, so we have log base 4 to the 6. I didn't do my work. 4x plus 6, because the exponent is on the other end of the equal sign. So we're going to minus 6 from both sides. So we have log base 4 to the 6. This is not being minus, like the 6 itself doesn't turn into 0, equals x, 4x. Divide both sides by 4, so you get log base 4 to the 6th minus 6. All of that divided by 4 equals x. So that would be your answer for the first one. Log base 5 to the 1 equals 6x minus 2. Add 2 to both sides. Log base 5 to the 1 plus 2. We're basically solving it as though it were a normal equation at this point, because that's all it is, right? 6x, divide all sides by 6. So we have log base 1, log base 5 to the 1 plus 2 divided by 6. That's your new answer up here. And it might want it to be plus 1/3, but I don't know if it is that picky. And then log base 6 to the 3rd equals 5x plus 2 minus 2 from both sides. Log base 6 to the 3rd equals, minus 2 equals 5x. Log base 6 to the 3 minus 2 divide by 5 equals x. That's your new answer. Fill in the blanks of the table that shows logarithmic growth base 4. So basically what it's saying is log base 4 to the x. It's saying what will happen. So we know, 1 minute. Yeah, so basically what it's trying to find is when y equals any of these values, what does x equal? And basically the way that I would do this is I would turn it into exponential form, because that will make it easier to calculate. So I would do 4 to the, and then your y will go here, equals x, because your x is here, your y goes here. This is the same thing. So now when y equals -3, your x is going to be the same as 1 over 4 cubed, which is 1 over 256. When y equals -2, so 1 over 256. When y equals -2, you'll have 1 over 64. No, sorry. -3. Sorry. No, not 256. That's 4. This would be 256. This would be 1 over 64. I got confused there. So it would be 64. 4 to the -2 would be 1 over 16. 4 to the -1. So 1 over 16. 1 over 4. 1. 4. 16. 64. You're basically finding what is 4 to the -2? What is 4 to the -1? What is 4 to the 0? 4 to the squared. 4 cubed. 4 to the 4th. Like, basically it's asking that. It's really useful to have your logarithmic growth base. The base is the good key. And then convert it into exponential form. Whew. Sorry, I've been doing math videos all day because I've been late. And so I'm getting mathed out, but it's okay. Fill in the blanks in the table. Oh, that's a good idea. To say, if you start feeling overwhelmed, or like your brain is getting foggier and foggier as you go on, like, it's so okay to take a break. It's so fine to say, okay, I don't think that what I'm doing is going to be any more productive. I'm making myself more frustrated. I'm wasting time. I'm going to take a break, go do something either enjoyable or something that seems more manageable to me right now. That's totally okay. Go ahead and do that. Anyway, coming back. Fill in the blanks of the table and use the resulting points to graph the logarithmic function. Log base 5 to the x. So I like to, again, convert. So I have base 5 to the x equals, base 5 to the y equals x. So x, if that equals 1, y will equal 0. If it equals 5, y will equal 1. Yeah. wait. No, I'm confusing myself. It will look like this. And then, so 0, no. I'm confusing myself. 0, 1, comma, 0, 5, comma, 1. It will look like this. It's basically the inverse of your exponential. And it cannot be less than or equal to 0, so your asymptote will be there. And your thing will look like that. And this is, we're going to be getting into shifts and stuff a little more with logarithmic functions. Basically, the key to graphing a logarithmic form, you know that your point will always be 1, comma 0 if there are no transformations. You also know that your second point will be your base. So in this case, 5, comma 1, always, unless you have transformations. That's a different ballgame. Yeah, and then state the domain and range, the x-intercept, and the vertical asymptote of log 1/5 to the x. Express the domain and range in the interval format. The x-intercept is an ordered pair, and the vertical asymptote is a vertical line. Now, we know that when we have an exponential graph, let's just kind of graph this real quick. We have 1/5, right? 1/5 to the x. We know that we always start at 0, comma 1. And then we will go to our base, which is 1/5, and then 1. So 1/5, comma 1. And our graph is going to look like this. Our function, our asymptote still is at 0, x equals 0, because we still can't have anything equal or less than 0. And then it sort of goes like that. So our domain is going to be stopping at 0 and going to infinity. It does not include 0. Our range is going to be negative infinity to positive infinity. Whoops. Our x-intercept looks like it's going to be 1, comma 0. And then the vertical asymptote is still going to be x equals 0. I kind of went through that quickly. If you have any questions, please let me know, and I will answer as soon as I can. Have a good one.